things like population increase, climate change, where there's increased incidence of rainfall intensity, really put a lot of pressure on pipes that were pulled in not even 60 or 70 years ago. We're talking sometimes hundreds of years ago. So it's an accelerating degradation of an asset class that is really undersized and has a lot of pressure on it. Most of the time, that is the case where an operator will go out and put a camera in. But obviously, that's a non-ideal outcome for the customer and communities. You're placing risk on public health and certainly the environment. Neither of those scenarios is what I know water companies want. So we've done that on millions of examples of what could go wrong in a pipe, so that when our clients upload footage, they're able to get fast, accurate results and condition grade their sewers very quickly, so they're able to make better investment decisions.
Hey, Amanda, thanks so much for joining me today. I really appreciate it.
Yeah, thanks, Jack, for inviting me on the podcast. Very excited to be here. I've been listening along for sure.
So why don't we first start off by having a bit of introduction to yourself and the work that you do?
Yeah, sure. So I am one of two co-founders of VAPAR, but my background is civil environmental engineering. So back when I was an intern, I was watching 8 hours a day of sewer inspection footage. It's very it's a crappy job, but somebody has to do it. And that was my introduction into the civil engineering space, and certainly what VAPAR is working on now, which is automating the condition assessment of underground sewer pipes.
You sitting there watching videos of underground pipes. We've got to dive into that. And I need to ask you, why were you sitting there watching videos of underground pipes?
Yeah, so watching underground videos, very weird thing to think about. But if you think about how much underground sewers there are in the world. So there's basically billions of kilometres of underground sewer pipes in the world. Each metre has to be watched to make sure that there's no blockages or breaks. And basically they'll put a camera down these pipes and drive them along and try and find these blockages and breaks. All that footage is manually reviewed. So people like myself have to sit there and watch hours of inspection footage of what's happening in a sewer pipe and document in detail what exactly is going on. They're underground, they're invisible basically, so you have to put a camera in, and that's why it happens.
Wow. It sounds like really mission critical work, right? We wouldn't be doing that if we didn't have to. I've worked in the water industry for quite a while now, and the thing that always surprises me is the scale of infrastructure that is required to be able to provide this clean water and wastewater system, infrastructure network, yet people don't quite acknowledge the scale of it. And hundreds of thousands of kilometers of underground sewers, of pipes and everything. And it's this massive big world that just lives under the surface that often your sort of average person just doesn't really understand the scale of.
Yep.
But then I guess the fact that it's hidden means that it's probably a little bit more tricky to get to when things go wrong.
Yes.
Right? Working in the water industry, you hear about the evil wet wipes and blockages and everything. So things do go wrong.
Oh, big time. And when they go wrong, they go really wrong. There's lots of sewage in people's front yards. Unfortunately, sewage in people's houses, raw sewage that goes into waterways. So there's a huge impact on the environment and public health when things do go wrong. So yeah, that's why it's really important to get ahead of the issue.
So in terms of these sort of blockages, I gave the example of wet wipes or something, but so things getting caught up in the pipe, and it causes a blockage. And would you mind just talking us through the process in which something can go wrong?
Yep.
And then the consequence of that?
Yeah, for sure. So as an example with the wet wipes, a lot of the occurrences that happen with wet wipes is it's not just one wet wipe that causes a blockage, but it's a build up of those wet wipes. So as an example, in a pipe that was laid maybe 30, 40 years ago, over time, those joints become, we call it splice, but they become separated. You have root intrusion sometimes because tree roots are trying to find water sources, but also those joints, when they're separated, catch wet wipes. And so once there's a small buildup of debris, that basically escalates the problem, and more debris starts building up in the pipe. I don't have to go into the details of what debris is in sewer pipes, but certainly there's a buildup of debris in the pipe that impacts the ability for that pipe to carry sewage to the treatment plant. and then slowly but surely a blockage starts to occur, and then it backs up to the only point that it can, which is usually someone's house.
Oh dear.
Yeah.
Yeah.
Indeed.
But you said like 30, 40-year-old pipes. And obviously the sort of population increases and everything, the pressure and the demands that society are putting on these 30, 40-year pipes. I imagine this is probably having a bit of an impact to the condition of these assets.
Yes.
What does so that sort of asset condition piece? I imagine is a bit of a challenge as well, right?
30 and 40-year-old pipes is a best case scenario. I know, you're from the UK. There's certainly older pipes in the United Kingdom than just 30 or 40 years. We're lucky in Australia, where I'm calling from. A lot of our pipes are put in the 60s and 70s, and yeah, they're coming to the end of their design life. But we actually have separated system here where we've got sewer pipes and stormwater pipes completely separated. So when it rains, it goes through stormwater, and when someone's flushing the toilet, it goes through the sewer pipe. A lot of the UK system is actually what we call combined. So rain and flushing toilets use the same pipe. So you're right. Things like population increase, climate change, where there's increased incidence of rainfall intensity, really put a lot of pressure on pipes that were put in not even 60 or 70 years ago. We're talking sometimes hundreds of years ago. So it's an accelerating degradation of an asset class that is really undersized and has a lot of pressure on it.
So this sort of continually expanding problem of the pressure put on our existing assets, issues happening. How does the water industry typically respond to this challenge? I imagine it's probably quite reactive, right?
Yes, it's a very reactive workflow, mainly because these pipes are underground. It's out of sight, out of mind, and it's very infrequently that we actually get a camera going through. So it's reactive in the sense that oftentimes water companies or water utilities will wait for a customer to call up and say, "Hey, I've got literal stuff in my basement or in my house." But the really exciting thing that's happening is this movement of asset management thought leadership that's coming through a lot of the policy frameworks and the legislation, even in some countries, to mandate or at least recommend condition grading of assets. So not only civil pipes, but just assets in general, public infrastructure that makes sure, do we have the right steps in place to ensure that future generations can enjoy the same assets that we have today? And are we setting ourselves up and the future communities up for success with the investment that we're making? So not just consuming the assets now and then leaving nothing for the next generation, but what investment in maintenance and in renewals can we do now to make sure that, we give everyone equity to assets.
Asset grading. So how does that work?
Yep. So what we do, and this is not just for sewer pipes, but all infrastructure, is we do a condition assessment. So we check the condition of each asset. And so in our instance, we do it using visual condition assessment, so off of the video footage, and determine basically whether that asset is operational and fit for purpose in a service sense. So can it work operationally? And then what is the structural integrity of that pipe as well, or that asset? So structurally, can it perform? So there's two main indicators that works off of, and there's an international manual on how to do this, but it's generally like a 1 to 5 grade. So 1 being new pipe just installed or new asset just installed, and then 5 is it's completely blocked or it's completely collapsed. There's a generally accepted way to grade your assets to make sure that you understand, okay, I need to focus on my 5s, which is the worst, and I can leave the 1s to when they show signs of wear. So that's a way that most asset owners or water utilities try and view their investment decision making.
So this current approach around sort of asset condition grading, it sounds very sensible. But does that still mean that people are having to watch videos of what's happening in pipes?
Yes, so that's the unfortunate part of a part of this whole process is whilst we've got this really good framework to do the condition grading of assets, there's also a very manual process that's involved in applying that condition grading. So people have to sit there and watch footage or go and inspect these assets, very manual process, but it also introduces subjectivity and inaccuracies in the process. That's the case for anything that you get people involved in. So that's where there's an opportunity to apply a different way of doing things, new and latest technology to introduce better accuracy, remove that subjectivity, but also increase the pace at which you're able to digitize the condition of assets.
Do most pipes already have cameras within them, or is this still a bit of a hurdle that we need to get over?
So most of the pipes underground don't have any cameras installed. They're actually cameras that sit on little wheels or have little wheels installed on them, and they're tethered back to a truck. The way that it works is a field operator will go out and find the right maintenance hole, open it up and put the camera in, and remote control drive it along from the truck, and then stop and pan and tilt the camera head whenever they see a kind of feature of interest, and sit there and write down what type of defect or feature that might be. But that process is super manual as well. Finding the right maintenance hole is very challenging. And yeah, they're not installed cameras. They're cameras that get driven along and then pulled back out.
And am I right in thinking that these operations engineers only go out when there's maybe been a severe incident, maybe something that's affecting a customer? Is that right?
Yeah. So in the reactive use cases, generally they'll go out. So reactive is where a customer is like the sensor for the network, where they've picked up there's an issue in their front yard or in their backyard or anything, and they've picked up the phone and called the water company and said, this is what's going on. So yes, most of the time that is the case where an operator will go out and put a camera in. But obviously that's a non-ideal outcome for the customer and communities. You're placing risk on public health and certainly the environment. Neither of those scenarios is what I know water companies want. Being able to be more proactive about their decision making and their inspection program is certainly something that they're all targeting.
So shifting to a proactive approach, is the plan to introduce sort of permanent cameras into the network, or like almost like CCTV?
Yeah, like permanent CCTV. So interestingly, what we have seen is just doing more inspections. So being able to add additional capability in the inspections. We've also seen event duration monitoring on key points in the network where there's known failures, where we know that there's structural issues with the network that we just don't have the time or money to fix at that point in time. There's a combination of technology that's being laid to try and address this so that we're not impacting customers. But first you need to find out what's going on, find out the areas where there's black spots or you don't understand what blind spots in your network. And that's where getting a camera in is super helpful. And then you've got other technology that can be layered on to make sure that the impact on customers is minimized, but you're making sure that asset has the design life to keep going. Yeah, so there's so much new technology that's coming through, a lot of which is on the podcast that you run. One of the ones that we apply is deep learning. So that's basically a subset of machine learning that focuses directly on videos and images. So it's basically turning the RGB pixels in the images and the videos into something that's machine readable, and you can analyze and make basically patterns off of what it's learning. So you can teach a deep learning model what a tree looks like, what a cat looks like, and in our case, what a blockage looks like or a sewer defect. So we've done that on millions of examples of what could go wrong in a pipe, so that when our clients upload footage, they're able to get fast, accurate results and condition grade their sewers very quickly, so they're able to make better investment decisions.
It's such a sort of light bulb moment to be like, hey, listen, we don't need to watch these videos anymore.
Yep.
A computer can do it for us.
And the crazy thing is, you're not going to find many people that will fight you on that argument, right? There's who wants to watch the insides of sewer pipes.
Yeah.
I've done it. That's not me. So that's the really cool opportunity here, is that this work is not only repetitive and manual.
How does the output of that sort of deep learning find its way into the decision making process?
Yep. So we talk about and think about what we do and certainly our product, as an additional member of the team. So an additional member of our client's team, it's going through and it's basically triaging which pipes need the most attention and the most work. And so it allows and gives space for somebody to come in from the organization to say, yes, no to whatever the AI has found. So once inspection footage comes from site, so from the pipes, gets uploaded and processed by our platform, then the platform goes through and says, look, these are my initial thoughts, but let us know what you think. And there's a very defined decision making process, not only on what needs to happen, but we can also provide that information by cost, by time, so that there's a clear decision making path on what needs to be invested and when. And I think for clients, that is a really helpful process because they're basically trying to keep, and I guess all asset owners are trying to keep their assets in service as long as possible so that they can, future communities can use that asset and have that service. So there's not enough, I think, certainly from what we've seen and heard in the market and research, there's not enough money available, public money available to keep these public assets in service. And from their point of view is, if I've only got this small kitty to spend, which are the most important assets, the highest risk assets for me to spend that money on?
Being able to actually almost get ahead and predict the problem almost before it becomes a problem.
Yep.
It must just save an absolute fortune, because you no longer have this significant customer issue, there's sort of this very bad customer experience, but also the cost of actually remedying the situation must be a fraction compared to what could have been.
Yeah, definitely. So we have stats to show that a reactive repair on a pipe is 4 times more expensive. And those numbers are just, a lot of organizations, rightly so, just don't have the budgets to put in a proactive program, but the benefits outweigh the costs in the long term. Certainly what the granularity of asset condition that you can get with AI means that you don't have to choose between quality and quantity. You can get the really fine granularity really fast. And the key with that granularity is a crack in a pipe will lead to a fracture in a pipe, will lead to a break in a pipe, will lead to a hole in a pipe, will lead to a collapse. And so if you can pick up that crack, and you're able to pick up that crack with AI because it's not fatigued, it's not biased, it's not subjective, and you're able to pick up that crack, it's like almost an early detection of what is going to happen in 5-10 years. And so you're right, that proactivity and that ambition to be proactive is certainly why a lot of people are gravitating towards artificial intelligence.
So I imagine the previous challenges that we had around not having data, we're probably getting through that.
Yep.
And it's now actually turning our attention to, okay, so how can we apply as much intelligence to this vast amount of data?
Yep.
To then be able to provide some actionable insights to our operations team, our asset management team, etc.
Yeah, there's a huge push on creating digital twins. I'm sure it's a very common phrase used on this podcast. Yeah, there's a huge push on digital twins, not least of which on the invisible sewer pipe network that we have, and all of the pipe networks that are underground. And yeah, that is really helpful when you've got no visibility, but also a critical service that you're providing. A lot of the monitoring that is happening, particularly in the UK, we see it as well in Australia and in the US, that there's a lot of event duration monitors being put in to test where is the level of sewage in my pipe or in my manhole or maintenance hole. And that's really important to be able to determine how much time do I have before this manhole or CSO is going to spill. But that's complementary to, like, is this pipe structurally sound? Is this pipe open or is it completely blocked? So that sort of information really dovetails with event duration monitoring. So being able to understand the condition, being able to understand the serviceability of the pipe. So yeah, it's a very, very complementary data set to create a full picture of what is going on in my network to create a digital twin.
I love it. There's so much opportunity around actually being able to just take more control of our infrastructure network through all of this new data coming to light. And it really does create this opportunity around like an ecosystem of all of these different specialist solutions to then link up and just ultimately create a lot more of a sort of proactive management system.
So this is like you say, there's so much data that's available, and it's really about, and then it creates a challenge for the asset owner, water utility, water companies to paint a story with that data. because we're basically, as a supply chain, giving people the paint colors. It's up to the asset owner to really create that picture. And I think that's what's really exciting as well about taking off some of these manual repetitive tasks, is that we're freeing up a lot of our clients to get into the data. What is the data telling them about the story of their assets and their networks, and gives them the opportunity to like look up and say, actually, this data set and this data set are telling me this story. I validated it with my ops crews, and I think this is the best use of my limited funds to deploy on this part of the network. Yeah, it's a very exciting time to have more data, but we also need those kind of next generation skills to make sure that data tells the right story.
And hopefully eliminating the future Amandas having to sit there watching lots of videos.
Yeah, exactly. Oh, that would be great. That would be great. If no one had to watch a piece of footage ever again, my work would be done.
That's it. Amanda, thank you so much for your time. It's been absolutely fascinating. I really appreciate it.
Oh, thanks, Jack. Appreciate you having me on the channel.